Okay, so so I just wanted to have a catchy slide. One of the things that led to this presentation was I work on an open source project called JClouds, and we have like 100 different various cloud providers to make connectors for. And all of them run the gamut about what REST is, and there's a lot of reasons why things look like they are. And so I figured it would be a good idea to actually take that knowledge and try and package it up. And if I can use big, bold, all caps fonts, then that's also good. So problems we're going to discuss really as the agenda is a little bit of background, why API, and then sort of like differentiating what different people say or what they mean when they say REST, because it is a fairly ambiguous term. And then we'll look at some design patterns that are applied to APIs, like real ones. So that's my Twitter. I'm an architect for a cloud hub at MuleSoft around the corner, which is an integration SaaS thing that you can make like data loader tools for Salesforce and stuff with. Also founder of JClouds, which focuses on infrastructure and storage APIs like EC2 and S3. Want to thank the folks that contributed. So the way I normally do sessions and topics is I go and ask everybody what their opinions are, as many as I can actually get, and sometimes it's more of a fire hose than others. This time it was a bit of a fire hose, to be honest. If you ask people what their ideas are in REST, lots of people will share them with you. There's a Google group called API Craft, which is pretty handy, and that's a bunch of folks that I think they call themselves REST pragmatists. Matt Stevenson, who's actually a member of the JClouds project, also has worked at Amazon Web Services in the past and gave some insight about that. We've got Greg Campbell from Twitter, who gave some insight about how their APIs work. And of course, the muleys that I work with, who we've had series and series of debates about API practices internally to try to help guide people in the right direction. So that was also helpful and very conveniently timed. So the first thing is, why do we API in the first place? Like, what's the point? And a lot of people feel like they need to put something up there, but it's really handy if you know sort of like what others' motivations are. What I found, and I've worked in ecosystem engineering for a few companies that have REST APIs, including VMware, and the biggest thing people are looking for is more collaboration and aims to grow their ecosystem. So when you have GUIs and all that, right, people can interact with them by the ways that you've already defined. It's sort of like the pre-2006 cloud model, where there's like these elastic services, but you've got to use the software somebody already wrote for you. And within the API-driven world, what you do is you sort of change that so other people can actually write software against your back-end services and make meaningful and interesting tools with them. That facilitates innovation, and that's what people want to do. You want to be a building block for other folks' innovation. And I think we could probably have a long discussion about other folks, and I want to hear your opinions at the end. But these are some of the aspects I think are really the motivating factors behind why doing APIs in the first place. And in the how part, a lot of folks start with a decision tree. Okay, is it going to be REST or is it going to be SOAP? And I'd argue that it's more like REST versus WS star, because what are you looking for from SOAP? Are you looking for the attributes that are more standardized relating to transactions or relating to any of the other identity services that are actually well defined and out there? And folks that have strong feelings towards some things that are not standard might end up going towards REST. And there's a pretty interesting book by George Rees where he actually is pretty publicly not so much a SOAP fan or a WS fan, but he uses it internally for other in their systems interconnections. So you don't have to have a conflicted relationship with APIs. You can choose. It's mainly what is guiding you towards that. Because this is a talk about REST, I'm not actually going to drill down into WS star very much, but suffice to say that there are other factors involved. And one of the interesting things about REST was actually defined in the year 2000. Right? So Roy Fielding's dissertation on the topic, which you could Google now and then not hear anything I say for the next 10 minutes, was actually made quite a long time ago. And so a lot of the WS star specs were actually made after this dissertation was defined, and so there's some interesting things in history, and it's actually really, if you look back and you see, like, now here we are 13 years later nearly, and there's still this catch up with REST, and so it's to me, like, the history of REST is a fascinating topic. And so luckily we have the internet, and you can find all sorts of documents along the ages. But what I'll do is I'll try and focus on what I feel like a lot of people are contending with today, which is sort of REST versus REST-ish. And REST-ish is pretty much what everybody does, and REST is pretty much what hardly anyone does. And I'll get into that. And that's not a judgment either, it's just the reality. So it really ends up being people feeling, okay, I need something that's not SOAP, or I'm doing something that's angled towards a very specific style, which you can pronounce it however you like. I've heard a few things: hideous, hideous, and hideous. So choose your favorite pronunciation. But the idea is that you have a structure of crafting APIs that has some design tenets, and you can go and pick everything out of the book, or you can cherry pick certain things. And what I've noticed in practice, actually, there's a pretty interesting thing you can do is actually go to Stack Overflow and ask about true REST APIs, and there's like 6 topics, and only the closest one might have been Netflix, actually. To actually the strictly defined public service that's 13 years later actually using the more strictly defined REST. So when I say strictly defined REST, what do I mean? Well, I've seen a bunch of different content about like what REST is, and there's basically an idea that there's levels, and the level 0, is where a lot of folks started when they were just putting APIs on top of their things. And this leveling suggests that you will end up eventually at level 3. Who knows if you will. But if you ever hear someone say level 3 REST API, you're about to understand what that means. There's only a very few amount of places where you would ever have anyone say level 3 REST API, I'll also admit. Doing the research for this talk, you end up getting into these worlds and these spheres, and there's spheres inside of spheres. So I'm going to just give you some ammunition and save you a month of research. So swamp of Pox, plain old XML. So the most common example of what's called a swamp of Pox API could be SOAP itself. From the perspective of REST folks, anything that basically uses payload as the only aspect to figure out what's going on is a level 0 API. So that means that if it is a GET, you don't know what's going to happen. Maybe that GET is actually going to delete every resource in your entire company. Who knows? You cannot tell from the way that the API request is structured outside of reading the payload. And so this does say XML. You'll see in the next slide that you can argue the lines. Is XML important? Probably not. The main idea is that there's a single API for all resources. There's a single endpoint for all resources, and you have to look inside the payload to figure out what's going on. Resources is the level 1. What that's saying is that through the URI you can determine this, what's actually being affected, even if you can't determine what's happening to it. So this is a fairly strange example. What you're seeing here is actually the Amazon EC2 API. You could argue this is actually a Pox API, because For example, it's not there's a base server path, right? ec2aws.com. There's nothing in the URI to distinguish. It's all in query params, and in fact, that could actually have been form encoded. And then, if we're talking about comma separated values versus XML, what's the big difference? So you could argue this as being a Pox API if you wanted to. However, what resources say is that there's something suggestive inside the URI where you can tell at least what's being affected. You cannot necessarily tell what's happening to it based on like HTTP verbs. And you can see, for example, here, the resource and what's happening to it is conflated in the same word. So delete volume is action, right? So it's actually conflating two things at the same time. So basically, the side effects are API specific. You can get an idea of scope by looking at it, but you're still going to need to understand the API to understand like exactly what's going to happen if you do something like this. The verb approach is where most APIs that suggest they're RESTful are actually doing. So verb approach basically says, okay, we now know what the scope of something is, but we're actually going to use more aspects of the HTTP request and response to allow people to understand what's going on. So, and it's also more prescriptive. So sometimes people think of REST APIs or web APIs as like CRUD. It's sort of CRUD plus or CRUD with a little bit more gravity. So for example, there's things in the HTTP spec about like idempotency of certain commands. Like for example, if your verb is head, it's not supposed to affect the resource in any way. The only thing that's able to affect multiple resources besides what's specified on the line is post. So there, if you actually look sort of verb by verb, then ideally you can have get a good sense of what's going to happen to the resource without knowing what the API is. And so that's a handy framework to actually work within. It also and it's not just the request. So in this request, what we're really looking at here is something where things are encoded within the DNS name. So the resource affected is actually my bucket, which is a subdomain there. Head, I already know S3, so forgive me for knowing too much, but I could guess based on head that that's actually not going to return the entire bucket here. It's actually just going to give me metadata on it. And that you can sort of get a gauge and some intuition with the knowledge of the basic frameworks of HTTP and understand what's going to happen. Also, what's the response code doing? So for example, if it's 200 or 201, I might expect some content back. If it's 202, that means accepted, meaning that something is going on beyond. It's not a synchronous command. They just accepted the idea. So you can actually look at the response code and get a good sense of what's happening. And so it's more than just verbs. There's just a lot more meaning, and that's why people have kind of gravitated towards this. It's concise. It's not overly prescriptive, but a lot of times you do have to affect resources, and you do need to know generally what they're going to do. It helps with caching and all sorts of other aspects that you need to deal with APIs. The level 3 is Hypermedia, and this is the Roy Fielding the HOS thing, right? So I have found one API that is I would say purely RESTful in that way. It's not an extremely popular API outside of like the domain of infrastructure folks, but vCloud is actually more RESTful than Netflix, which is the only one that I could find that's actually somebody might recognize. Why do I say Netflix isn't? I don't actually have a screenshot of Netflix, but Netflix has a very specific structure of the HTTP paths, and you can decide what's actually going on. Mainly, all the documentation discusses aspects of the URI. So, for example, here you can see there's some hints like catalog item. but generally speaking, in truly RESTful APIs, they are always going to say that href is just an ID. So treat it nothing else, because everything you need to do with that resource is defined by its links. So just use that as the ID to get access to that resource. If you want to store something, store its href. But to tell what you can do, it's the idea is that you're not actually looking at documentation. You're going to say, okay, I can tell what to do by virtue of whatever links are present. So, okay, I can remove it because there's a remove link here, or I can edit it. And there's a mapping between some of these relationships, which are defined in various specs, that you can actually say, okay, what command would I use to remove? So that would be delete. What would be edit? It would be a put. In RESTful natures, it's a little bit chattier in the hypermedia controls, because, for example, update or edit is intent as a replacement command. So you're actually supposed to send the entire text. So you'd have to get the previous XML or whatever it is, and then actually push the entire object back. So it's sort of like a synchronization protocol in a way. So the things that are handy about it is sort of the way you can walk and discover things. So one of the things about Roy Fielding's definition is that you shouldn't need documentation to discover what to do. It doesn't mean you shouldn't do documentation. It's just that everything's discoverable. You enter the API, and then it will have like downlinks for all of the resources inside of them. And so what happens is that you can actually discover new resources and new actions on resources as you go. So it's actually, you know, if you're looking at level 2 APIs, generally speaking, what happens is you look at their documentation page, or maybe something called Waddle, which you found on their documentation page, and then just by that type, you can figure out what you're doing, because there's a type associated with a specific version. It's not that hypermedia APIs are not typed. It's just that they're typed at a finer granularity. So, for example, you can see the accept header here specifies that, okay, in this specific view, you know, in this XML view of this resource, that's what I'm actually interested in. And so as long as you have a mapping to what these various resource types are, where normally what you would see like application XML or application JSON, you're seeing here actually a vendor type. So the type is actually not per API with a list of predefined types. It's actually per resource, and you just discover them as you go. One of the interesting things about this is like, how do you decide what those types are about? So, for example, in vCloud, their Discovery API has links to schema for each of these types. And so there's some things that practically you have to do if you want to support it. So, you know, what's good, you know, about something if you're publishing an XML, most of the time people are going to want to know exactly, you know, what's inside of there. The fielding definition really only defines the fact that there would be links inside, but not necessarily the form or structure of the documents. In fact, that's the point. The point is actually to have more of a framework that's self-documenting than to create a type system. So Hypermedia is really, it's very interesting. And I have to say, when I first worked with Hypermedia, I didn't like it at all. It's grown on me, but I'm a bit of a bi-restual. Like I don't mind partaking in both the Type 2 and the Type 3 APIs. So let's think again about these transitions. So I mentioned these links, and so all transitions are discoverable by links. So if we looked here, we saw these links here. What does that basically hint at? It hints at a state machine, right? So HTOS really stands for hypertext as the engine of application state. So state machine. And that means that you know, you're aware of the valid transitions based on the links that are present in the response. So, for example, there's a number of standard relationships, and what you might end up having to do is define new relationships because of the domain of what you're working with. So, for example, if I'm working with a virtual machine, I might need to attach a disk to it. Well, that's not going to be in an HTTP spec someplace. So you might actually have to namespace and create new relationships to represent the new states that are actually valid for this resource, which again hints back to the fact that you still need to document things even if they say they're self-documenting. The interesting thing about the the truly REST-y one is that it maps very well onto permission schemes. So in a way, if you look at a level 2 API, you can find out what you don't have access to by trying to do it and see if you get an access error. Because you don't necessarily know if you have fine-grained permissions model what you're able to do until you actually do it and fail. There are very few APIs that actually have a meta model for figuring out what commands you're allowed to operate against. In the hideous style, think of permissions as just a mask on your state diagram. So if you're not able to edit things, then the edit link would not be there. If the server is down that you are supposed to be adding something to, then its edit link wouldn't be available. So what they're trying to do is basically say that, think of it truly as a state machine, and when you design your APIs, keep things like permission masks and everything else in mind, because that can help, particularly with graphical renderings where you don't want to give someone the option to do something they're not allowed to do. So it's kind of interesting how that works. And this is, for example, in the JClouds work that I've done where I've worked with the various versions of vCloud. That's how we figure out that we're an admin user. It's like, okay, well, is the admin alternate view present or not? If it's there, then I'm probably an admin user. And what does it even matter? Because if you're admin user, you just happen to have this role. As long as everything's represented by links that you can access, then you don't really care. You just need to know what things you're trying to do and if they're present or not. So that's something that's highly prescriptive. And so that's another way to figure out whether you're talking about a level 2 API or not, because if the API doesn't have links, it really can't become a state machine whose transitions are visible via API. I'd say one last thing on this one before I ramble on too much is that it's not terribly important how the links are rendered. So the links could be a part of a JSON ball. The links could be a part of an XML document. You could actually render them as headers. And some folks actually do that so that they don't interfere with the document itself. They'll just add link headers, and there's a link header specification too. So just because, for example, you're returning a binary file or something like that, it doesn't necessarily mean you can't use links. The biggest part is, and I hinted at this earlier, is the content negotiation part of the truly REST-y things. So a lot of folks they're either used to specifying something like XML or JSON or nothing at all and just understanding it will be returned. The content negotiation doesn't actually mean a fully spec'd out vendor-specific thing. It's just in the context of hideous, they're really referring to doing things like versioning, if there is any, at the resource level. And that would be, the content type for that particular HTTP path. So what this allows you to do, it allows you to present multiple versions of the same resource and even do things like versioning at the granularity of a single resource as opposed to the entire API. So it's very fine-grained because, for example, if I have a media type for tweets or something like that, I could actually update just the content type of that tweet to like semicolon version 1.1 and upgrade that single component inside the API without breaking anyone else. So the responsibility is on the client to present what they're capable of dealing with. So what happens is that you can actually support older clients because they will continue to present the old media type. So one of the things that's interesting about dealing with hideous APIs is just the acknowledgement that clients are aware of certain resources. They don't always update their code and discover their way through. So you may end up having to keep keep different versions of your code. And how is that represented? It's represented as having to deal with like different versions in the accept header, as opposed to like a different version in the HTTP path. So on a change, first off, if it's a non-breaking change, generally speaking, people don't change either the resource definition here or add a version number. Basically, if they say if you add it, if you defined your API as one that's going to have the practice of adding fields, without incrementing the version, then your users will just work. Now that doesn't always work because, like for example, in practice, I've noticed a lot of people who have their own custom parsers or whatever can break just on a presence of new fields. So it's still a design decision of what you mean when you say like non-breaking change. But at the end of the day, there's two choices to change versions in the hideous style of a specific representation. One is actually to encode it in the name. So you'd put like -1 or something there at the end of whatever the resource is. So say if it's canoes, it would be canoes -1. Another way would be to do semicolon version, and then whatever. And a lot of folks would put like a major minor there. I was talking with Dan Feist from MuleSoft about this, and he actually helped present this breakdown of impact of versions. And one is that there's still a chance that you're actually overhauling the meaning of these types, or they're so different dramatically because the whole thing is an overhaul. And that's sort of the difference between creating a new API in general and actually just updating a media type. So, for example, if we go back to the vCloud thing here, you notice they also put the version in the path, and there's a couple reasons for that. There's an operational reason because it happens to be represented as a Jetty WAR, and it's very easy for them to deploy things as that. But the other thing is that in their major versions, they have actually changed the entire scope of a resource. So, for example, this is again, it's a virtualization API, but they would have like networks that are defined at a higher level scope in one version, and then in the next version, it's actually at a completely incompatible scope. So in that case, they actually bump the whole API. So even when you're doing media type versioning, you may still get into a situation where you're actually semantically you're thinking about actually a different API or just incompatible relationships, and then you may still have to have like a global version, if you will. So a lot of folks, and I'll admit myself here, is that find the hideous style elegant, and it's pretty impressive because again 13 years, a lot of people trying different things out there. It does hold its model pretty well. Clients always know what their transitions are. They don't have a lot of surprises, or that's the idea. You can be very granular with your versioning constructs. All this we just reviewed. You might say go ahead and use hideous as your style for creating APIs. And the first thing you'll probably encounter is a perception of complexity, because what's happening is if you like for example you get to a finer and finer granularity, folks that are not used to that particular granularity might perceive that as additional complexity. And this is the real balance of API development in general, and not necessarily even related to REST, is that you have different points of view where if someone who's looking for more and they don't see it, they'll think of it as a naive API. And if someone's looking for a certain amount of features and they see too much, they think of it as overly complex. So it's really it's not an easy decision anyway. And so I'll get back to this point later, but you do have to know your users well enough, or at least your use cases and what you're optimizing for, and be aware of that. The other thing is that it's not a crime to actually have multiple views of your services. You can actually have like a type 2 view, because the interesting thing is that the type 3 hideous REST full design, you can pretty much put anything on top of that because you have enough richness in the model to work with. So if you're using some sort, you could actually use like an integration flow to just convert a simpler view to a more complex view. The other thing is to remember what level 2 is optimizing for. Folks who write level 2 APIs are not thinking of themselves as level 2 out of 3. So I mean, they're intentionally designing things. Not everyone, but give them a benefit of the doubt that there's actually some design tenets going under, and maybe they're not inside of the same mental models as other folks. There's impact, but it's not necessarily showstoppers for using the level 2. And again, that's more like you've got JSON, or you've got put and get and delete mean things. The impact is that you have to do more coarsely grained versions because you're not actually addressing versioning at the resource level. And that also might impact the way that you deploy your API code. It doesn't actually mean that it must be deployed as a single monolithic thing, because there's all sorts of various ways that people do continuous delivery, and there's lots of talks here at Java 1 to talk about how interestingly people can push changes through an environment. So it doesn't necessarily mean it's monolithic or it's resource versioning. You can also have different ways to just deal with software deployment. It's optimizing for CRUD++. It's optimizing for a quick way to get the intent of what's going on. But there's a limited amount of representations, and so maybe they're easy enough to document. So for example, if your GitHub, is GitHub going to suddenly turn into a flower shop? Probably not, but then again, Amazon turned into an infrastructure provider. But seriously, a lot of people are not going to dramatically shift their APIs from day to day. And there's also other reasons why people version things. So I'll get into this a little bit later in depth, but you're dealing often enough with services. Like, it doesn't mean you have to be like a public service provider to treat yourself as a service delivery model. And so maybe you're actually versioning a collection of value that you're delivering as a unit, and maybe even that value has constraints on it. Like, okay, for example, the latest Twitter API release was really more about throttling concerns than it was actually API updates. And so you do have to package communication up somehow about what change is going on in your environment. And maybe people don't want to know bit by bit every resource. Oh, this resource is new. Oh, this resource is new because I crawled the API and found it. Maybe there's a communication pattern or some other reasons for bundling up features, and maybe that actually fits nicely into a more coarse-grained model. The other issue is today's tools. Now, I mean, I mostly do Java development, and if you look around and you use those letters, hideous, and then do that with Java there, you'll find like some incubating things, even though it's 13 years later. So for example, I've noticed that there's an extension to JAX-RS that's being sort of kicked around. There's some tools, I think Yayway guys in Sweden are working on some toolkits, but it's still surprisingly a work in progress. There's a Spring hideous, which is also evolving. And so the question is like, maybe you want to optimize for tooling. And sometimes even the way that an API is represented is because like Rails is easier that way or something like that. So sometimes people are optimizing for different aspects. And maybe those aspects are just what's on the ground and what are they able to use. The other thing is that there's this sort of like simplicity over elegance, or call it pragmatism, or however you want to name it. But there's some folks that strictly, say, a rock is a rock. This is this. It's not going to change tomorrow. Maybe it'll change in 6 months. But let's keep things simple. And this is a big debate. And to a certain degree, we have to ask ourselves: is it all just prickles and goo? And if you haven't seen this, it's on YouTube. But it's basically the South Park guys made a pretty interesting way of describing the folks who like types and the folks who don't like them in general, which is more an engineering discussion than a software discussion. But your culture might end up being the one that decides. So if your culture does not embrace something, And that's, for example, you're developing something and you're trying to attract, and we remember we're trying to grow our ecosystem. And right now our growth area that we need are more developers who don't like hideous. Then maybe I wouldn't put a hideous API in front of them, because what am I doing this for? And so you need to consider the culture of your consumers. So at the end of the day, I guess it's a really long-winded way of saying you need to know what you need and who it's for. And it's more about designers, and as designers, we understand that how it's used and who will use it is important, and getting feedback is important. All these things, there are impacts to design beyond development, but there are also impacts of design that are development. So there's scenarios where you might be better served with one or the other or both. So and again, the iteration, like how do you know unless you ask someone? So definitely socialize your ideas. So for example, Twitter is certainly not HOS. Somehow, some people would probably think their API is somewhat successful. I think there's been a lot of talks about their various APIs, including the recent improvements relating to streaming. So they actually have 3 different classifications of APIs under their bucket. They're all happen to be version 1.1, but that version doesn't really mean anything except for a collection of what our value is at the point we said 1.1 exists. That what they refer to as REST is an API that generally follows most of the level 2 things. Maybe they have an accidental plus new in the URI occasionally. But then again, we shouldn't judge too hard because their REST API is an incremental update, and it was defined in 2008. And not that that's ages ago, but a lot of folks are figuring out their ways, and maybe the motivations for what they were designing it for at the time were not related to what hideous is. And the other thing is that like in this room, when I asked about the Roy Fielding thing, not a lot of folks had heard about it yet, and that's still the case. So maybe even some of the designers didn't really know or care to optimize for the dissertation. Search is not REST. So search is basically, it's a query. Like, you're going to enumerate over various things, and it's not fitting in the strict models. And some search APIs are even more so because they're really just even like more like a representation of SQL over HTTP. But if that's what you need, then maybe that's something that's something that you want to optimize or at least allow folks to do. Streaming is an interesting one. I don't really hear a lot of debates about whether streaming is or isn't REST, because you could think of it as like, okay, I can make a content type called like, comvnd Twitter tweet plus stream or something. I don't know. You could do that, I guess. Content representation doesn't have to be a document, but most folks don't really associate streaming APIs with REST. And what do I mean by streaming API? In the case of Twitter, what would happen is that you would make a single HTTP connection, and then you would be streamed tweets as they occur. And with the popularity of real-time APIs, this sort of stuff becomes really important. If you think of it like this, search is sort of history, because at the point where it's indexed, it's already passed. And maybe there's things that were filtered out by the time the time that the search indexing happened. And so, if you're looking at a system where people are increasingly looking for, tighter and tighter feedback, like they want to see, okay, I want to watch this happen now, it might actually be a combination of many APIs that you use to achieve the goal. And prevailing, wisdom now is that, especially with things like tweets and everything else like that, that's a specific domain where things like streaming come in handy. There's other domains where streaming are important because, for example, the nature of REST often enough is that you're polling for updates. So if I want to know, like, maybe I have a container and it has all of my files in it, the only way to know that there's a new file in it is to actually keep issuing the GET and see that there's a new file link there. And streaming is a way to sort of like change that model so that you're actually notified when those things happen instead. And in fact, the interesting practice for Twitter is that they use a combination of REST and streaming to deal with reliability of connections. So streaming basically means you're making one connection. Well, what does that imply? You're relying on that connection because that's how you're getting the updates. So what if you're going through a cell and that drops? Then you've lost whatever that window was where you were getting streamed updates. So they have practices of supporting both and saying, okay, in unreliability or on your mobile, when your phone's on mobile, you'll do this, and then when it switches to Wi-Fi mode, you would actually use the streaming APIs. So there's some operational controls and contexts for certain types of APIs that sort of not just suggest things like streaming, but also suggest both. Amazon is certainly not REST, and they don't even pretend it is. They actually call it a query API if you ask them. But many people would say it's good. I mean, it's good. They've got adoption. They have massive scale, and if you talk to ex-Amazon engineers, they have all sorts of interesting stories to tell you about it. One of the stories I asked is like, why exactly was it made the way it was? And apparently they had an optimized HTTP server that's very, very good at splitting query parameters and parsing those out. And so because the infrastructure was made for that, it was very easy for them to achieve a scale of any given service by following these patterns instead. And if we look back at the API itself, this one here, like I said, all the content is delimited query parameters, and they're not very deeply nested either, which makes it a very simple model to deal with. Normally speaking, you almost serialize a portion of the XML in query parameters when you're dealing with an Amazon Web Services API. We go back to where it's good. Well, one of the advantages there is that it's very simple to extend this API because you just tack on a new key. And that's how if you follow any of the Amazon Web Services updates, they have updates every few months across the board with various APIs, and it's extremely simple and it doesn't break very often. It also helps them in their scale design for security because the way they deal with security is that they actually request a user to sign each HTTP request based on its headers. So because they know all of the state related to that request is serialized in headers, they know that any authorization model has everything it needs to know about if it has all the query parameters. Then they know that any authorization system will have all the context it needs if it has all the query parameters. So basically, it splits it up into a map. It sends that asynchronously to the authorization system, and it has a little race. This is what I've heard anyway, and that's that it will block until the authorization system is ready, presuming it's going to be a successful request. And then they just throw away the request if the authorization failed. So you can actually make some pretty low latency APIs if you do design for things that might not seem intuitive when you first look at them. So and I'm wrapping up the session here a little early because I want to make sure that you guys have time to give feedback because I totally used up all the time last one. But good APIs, and whether you're REST or not, the main aspect is a conscious design with your users in mind, right? So understand that. That's already part of your Agile process anyway, hopefully. So just REST is no different. REST is also a product. It's not just an interface over some implementation. It's something that's meaningful and important, and it serves audiences that might be different than other audiences. So just use conscious design. Versioning is not right or wrong. It's a scopes that matter and how they're applied, and that applies to your change model. And so if your users cannot embrace change on a daily basis, then maybe you shouldn't version on a daily basis. I mean, they're just conscious decisions to make. And there's certain things that I would say that are just sort of like I didn't talk about in depth, but try not to leak too many implementation details in your REST design. This is something that's happening more often as people try to use different like NoSQL data sources. Like for example, there's some aspects of design, test them against different potential backends that you might have, even if you, for example, think, okay, I'm just going to use MySQL forever or whatever. You know, if you do pagination based on something that happens to work very well in SQL, and then you're using NoSQL, or you're using an array of APIs behind it, then you know some other time, it might be very, very difficult to implement that. So try and throw more rocks at your designs from an operational perspective, because you want your API to survive your business plan, right? It should be able to perform and stay alive with it. The other thing is use auth models that are relevant to your ideal consumers. This is I didn't have a slide on this, but basically you'll see a lot of popularity with OAuth, especially OAuth 2 lately. For example, Google is pretty much wholesale over there. Twitter recently changed to OAuth, I think 1.1b or something like that. You can expect more and more services to move towards OAuth. I don't want to do an OAuth talk, but suffice to say, keep an eye out for that, because you want to be aware of the various types of interactions, whether it's a backend, whether it's a trusted application, whether there are humans involved, and keep that in mind. An auth model isn't an API, really. I mean, they're versioned differently. Like OAuth, when I say version 2, what does that mean? That's a version of something that's not your API. So don't conflate the two. But keep that in mind, like, because you know you should be aware of the auth models, because those by themselves can also interfere with your users and maybe not attract them, and then your ecosystem goal isn't well served. But at the end of the day, developers and users like to have documentation and examples, and so even if you use a hideous style, you know, great documentation, especially with literal requests and responses, is very important. With working with you know, a few dozen APIs that I've worked with, I can actually program an API completely offline just based on copying and pasting from the documentation on a well-defined API and a well-documented API. And that's very handy, because sometimes, for example, you know, your users are not going to have a lot of patience with APIs where they have to actually discover their way through. So, and again, it's a sort of the culture of the user. So what now? I'm actually not going to pitch API Craft. There's some folks that don't particularly like it. I like it. You can join it. It's a decent Google group, and they do answer folks. And there's a couple books here. George Reese is and I'm actually just noting the very short ones, because I know everyone has small attention spans. So both of these books are about 50 pages each. George's is longer, but it's got like a bunch of appendixes. So there's two books. There's here that you can have a look at. And there's plenty actually of material, because remember, this was 2000, so there's actually many other books on REST that you can look at. These are just quick ones that focus on design. But mostly socialize your ideas. One thing that I found very interesting in doing the research is just that there was not a single mailing list that was overwhelmed with too many people asking questions about how their design should be. Like, the maximum traffic might be 1 or 3 messages per day. What does that tell me? People are not socializing their ideas enough. Because, you know, if you go to a programming mailing list, you're like, oh, I can't get Eclipse to run or whatever. There's a lot of socializing, you know, whatever their constraints are. In design, I'd love to see a lot more folks like socializing what's working for them, what's not working for them, and questions they have, because that means that you can get a lot more feedback when, you know, for everyone. When the next person goes to create a presentation like this, they'll be able to get your input as well. So thanks for coming. I've got 10 minutes for Q&A. So yeah, go ahead.
Are the J-Wave presentations hard?
Yeah?
They're similar to what you're talking about in the 3. I said it's pronounced Hypermedia APIs.
Hypermedia APIs. Good. Yeah? All right. Thanks.
My question is around search.
Uh-huh.
If you're going level 3 and Hypermedia APIs, in practice, have you seen people create a resource which is like a searcher resource and then like just use get off of that with tons of parameters? Is that generally the happening to it all, or because it's an awkward fit, like you said, like how do you get the search in there if you're going by the query?
Good question. So the question was about search and how does that play out. So it actually, you can boil it down to nouns versus verbs. And there's a lot of, if you just like search nouns versus verbs rest, there's some long email threads about that. But basically, it's much easier to model nouns than it is to model verbs. So the idea of search, and people have passionate opinions about it, but search could be a resource if, for example, you're an Elasticsearch cluster. And you could update that resource, at least some pieces of the resource, because that's actually the thing that you're interacting with. But at the end of the day, a lot of people implement search as a cross-cutting concern across all resources. And when you have like a global search across all resources, it basically means that the representation is going to end up being columns, represented in some form. So that's where I kind of feel like it's more of like search as a query API system, similar to someone's representation of SQL or their representation of composite predicates or whatever, versus fitting strictly to a REST model. What I've noticed is a lot of APIs will like string on their filters on any resource. It's just those keys or those facets would actually be specific. So if I'm working with a server API, then maybe I would have filters on IP addresses, which are pre-canned facets versus like full text search over everything.
Where I felt the crunch was that when you're dealing with level 3, it's providing URLs. So you're not supposed to know the URLs, and so but if you want to search across all resources, there's no real way of providing the search facility.
And for me, that's actually why I kind of put search and streaming in a different bucket, because I haven't yet see someone, I'm sure someone will come up with it, but a clever way to actually represent a system except for providing a document that has the search keys in it. And then it just gets really weird. So I mean, I don't mean to be judgmental, I haven't seen anything that matches exactly the same hypermedia controls model plus search without cheating some way. Yeah. You had a question? Mm-hmm.
And beyond that, do you feel like it's necessary to set a policy up front about how you will replicate things, or do you feel like you just do it on the as-needed basis?
Sure. The question was on deprecation, and some people are very strict about it. Like I know in George Reese's book, he says like you should never deprecate anything at any time, and a lot of folks will say that, for example, it's easier to adapt an old model to a new model than to deal with specific, like when you're at the resource level, than to actually take those things out. In practice, these things are hard, and for example, Twitter says 6 months, 1.0 will be gone, and it looks like an EOL process on any other piece of software. Tricks about this, I think there's a API format called AUKI. I think they use, and maybe they still do it, but they used to advocate a deprecation header, like an X deprecation header. But again, this is the sort of thing where the API, as you're crawling through, you could present the new versions, and the client itself could actually continue to ask for the old version, even though the media type doesn't match. The other thing is just to remember that the accept header accepts multiple values. So a practice you could suggest if you're using accept headers is or any type of content negotiation is to use that, which is fully supported, to specify a list of things to give a transition period. from an API that's versioned at its root, then basically you need to have a way to eventually get rid of the old versions. I wouldn't say that there's a silver bullet for that. Those are the aspects that I've noticed. Either published deprecation policies, try and introduce a new header that would inform them, or simply not publish the links. Any others? All right, 5 minutes early. Go get your lunch.